Okay, welcome to day whatever. Day one. All right, we are jumping way up in chapters now. We are actually jumping way up to Unit 10 now. We can do something that's not too hard. We can do something that's not too bad with matrices, or we could go into the next section that's awful hard, but we're not going to do that. So we're going to spend this week talking about matrices. Again, it's kind of a nice little, this should be, for the most part, a nice little, I need to really help my grade out type of week. You'll have plenty of time pretty much all week to get assignments done before you walk out of here. You're going to have an assessment on Friday over this material, and it's really only 3 days of material. Today we're just going to learn what matrices are, do some addition, subtraction, some scalar multiplication. Tomorrow we're going to do multiplication, and then we're going to do kind of a combination part to them. So we're going to kind of puzzle it together and then end up reviewing on Thursday and having assessment over it on Friday. Then we're looking at next Wednesday is your final. And yes, you are going to have a final. Do I know what the final looks like? Kind of. It is a cumulative final, meaning it's covering from chapter U0 through, and I don't know if we're going to include any of this stuff on it or not. We haven't decided. We might put one on there, and you'll like it if we put this one on there anyway. But it is a cumulative final over the whole, everything we've done so far. About 20 questions. It's not going to be extremely long because you got 45 minutes to take it. So, or 50 minutes, whatever, to take it. So it's not going to be extremely long, right around 20 questions somewhere in there. We'll be pretty picky about the questions that we ask. It's open note, so you'll have your notes. But with it being open note, you got to be careful when you say open note because then you think you can flip through and look. You flip through and look in open notes, you're never going to get it done, and you've only got 45 minutes to get it done. So we're looking at, I think next Wednesday is the date for that. Also, your guys' schedules for next semester, they're going to be changing. I have no idea what it says right now. If it still says you had the same teachers you had before, obviously that's not going to be the case. What teacher you have, zero ideas right now. Right? It's probably more than likely going to be myself, Ryan, and Connor, Mr. Jones, Mr. Pizzer. I don't know. It's going to be one of us, more than likely, at this point. But that's not even determined yet. So it's kind of the preview. So matrices, what are matrices? Matrices are essentially old Excel spreadsheets is what matrix are. So when we're talking about a matrix, if you think about an Excel sheet and you think about the rows and columns that an Excel sheet has, that's what matrix are. They're made up of columns and they're made up of rows. So in a matrix, it's going to be something like you could have maybe a 4 here, a 7 here, a 3, an 8, a 2, a 1, and that's big enough. Okay, so this is considered to be a matrix. Now, matrices are made up of both rows and of columns. Okay, these are our rows. This is a row, that's a row. This is row 1, this is row 2. And then it's made up of columns, C1, C2, and C3. So the columns go up and down, the rows go across when we're talking about matrices. Now, we give matrices a dimension as well. The dimensions is always the number of rows by the number of columns. So in this case, there are 2 rows and there are 3 columns. So we call this a 2 by 3 matrix. Now understand that each of these numbers is its separate element. 4 is an element. 4 is the element in row 1, column 1. 2 is the element in row 2, column 2. 3 is the element in row 1, column 3. So we could have you name where elements are located. If you've ever heard people playing chess, you think about chess. If you've heard people playing chess, or you've played it on your computer. It'll say move rook to R4, 6 or something like that. I don't know. I'm not a chess player. But essentially it's telling you what row and what column that you're going to move that chess piece to. And that's kind of how the chess thing works. It's all based off matrix. But really, if you look at it, these lines obviously aren't here when we're talking about matrices. But in a sense, it's just an Excel spreadsheet. That's all it is. Okay. Now, we want to be able to do things with these as well. We want to be able to add them. We want to be able to subtract them. We want to be able to multiply them. We want to be able to do all of these different things with them. But first of all, let's just kind of make sure that we're good with writing down the dimensions. Again, when you're writing down the dimensions, remember that it's always the number of rows that you have by the number of columns you have. And there are specific rules to adding and subtracting and multiplying that we have to follow, and you have to have certain things happen with their dimensions. So it's important that you're able to take any matrices and give me the dimensions that it has. So if I have something like, there's no commas. If I have 6, 5, 3, 1, and 7, this has one row. It's got one row. This is my row. Hi, how you doing? McDonald's. So the dimensions for this, it has one row and how many columns?
1.
That's a column, that's a column, that's a column, that's a column, that's a column. How many columns does it have? 5. So it's a 1 by 5 matrix, the number of rows by the number of columns. Okay, so we've got that 1, 2, 3, 4, and 5. So we call that a 1 by 5 matrix. 3, 7, 8, 2, 0, 10. How many rows? 2. How many columns? 3. 2 by 3. Columns go up and down. Columns, the way I kind of keep it straight in my head is I think of houses. Those really like southern houses that have the columns out front. Like the Colosseums. The columns go up and down. Rows go side to side. That's the only way that I can remember. I don't know. It's silly, it's dumb, it's stupid, but it works for me. Can we do this? You're going to get more practice with this. So, in order to add or subtract matrices, say we want to take the matrix 4, 0, 7, 1, and we want to add the matrix 3, 6, negative 2, and 4. We want to add these two matrices together. First rule, in order to add matrices together, they have to be, or subtract them from each other, they have to be the same dimensions. If they're not the same dimensions, you cannot add them or subtract them. Okay, so this is a 2 by 2, 2 rows, 2 columns, 2 rows, 2 columns. It's a 2 by 2 and a 2 by 2. Then it's going to equal a 2 by 2 matrix. Now, the way you add them or the way you subtract them is you just take the elements that are located in the same spots and add them together. Ladies, hate to disrupt you, but I'm going to anyway. Add the elements together that are in the same spots. So 4 and 3 are in the same spot. First column, first row, first column. First row, first column. So what's going to go here is going to be 4 plus 3. The next one on top is going to be 7 plus negative 2. Down here, 0 plus 6. And here is 1 plus 4. Now, obviously, you don't have to write that down. I just wrote it down this time because I wanted you to see what you had to do. You know that 4 plus 3 is 7, and 7 plus negative 2 is 5. I hope you know this stuff. And I hope you can add and subtract. But that's your end matrix. when you add those two matrices together. And again, it's just like a spreadsheet. You're adding this one and this one together to get something new. That's all you're doing. Subtracting, kind of the same way. They have to be the same size. So if I have -5, 6, and 4, and I'm going to subtract -2, I did a comma again, -2, 3, and 1. I've got a 2 by 2. I've got a 1 by 2, 1 by 3. I've got 1 row, 3 columns. I've got 1 row, 3 columns. It's going to create a 1 row by 3 columns. Now, what you have to be careful of when you subtract is that you're subtracting them. So in this case, it's going to be -5 minus -2. It's going to be, me running out of room, erase. It's going to be 6 minus 3 and 4 minus 1. So you have to put those things in there. -5 minus -2 is -3. 6 minus 3 is 3. 4 minus 1, that's really weird. 3 and 3. Like I tried to do that. Anyway, hardest part of this subtracting is making sure that you subtract them. So when you subtract, sometimes it's better to write this down first, because then you don't forget. Again, the first one, just kind of like when we were doing polynomials, adding and subtracting polynomials. You had that parenthesis there. I told you to rewrite it by distributing. Some of you can get away without having to do that. If you can, great. If you have to write it down, then I guess you have to write it down. Not that big of a deal. Okay, let's try one more. Now have you try this one on your own. Let's go 1, 4. Actually, we're going to do 2 more. 6, -3, -2, and 1. We're going to subtract from that matrices 0, -10, 3, 8, -4, -1. So go ahead and subtract those two matrices and give me the end result. Look right. Answers on the board, I think. Looks right to me. Just got to be careful with that subtracting. To break out the calculator, you have to break out the calculator. Any questions with that? Now again, remember, they have to have the same dimensions. So if I try to do something like this and add those two things together, we've got a 3 by 1 and a 1 by 3. You can't add those together. So what you put if this takes place, These are undefined because they have to be the same dimensions in order to add them or subtract them. Okay? That is not the case for multiplication. And we'll talk multiplying two together. We'll talk about that tomorrow. Okay? But it does hold for that. The multiplication that we are going to talk about today is we're going to talk about scalar multiplication. We're talking about scalar multiplication. We're talking about taking something, let's say 5, and we're going to take that 5 times the matrix 4, 2, -1, and 8. This is called scalar multiplication, where you've got this single number that you're scaling essentially your matrix up by, or down if it's a fraction. You're scaling it up by. So we're essentially saying we're making this matrices 5 times as big as it is right now. So in order to do that, we are going to take that scalar, which is 5, and we're going to just multiply it by each of the elements, because each element in the matrix is essentially getting 5 times larger. And again, this was only for demonstration purposes. I completely expect that you could do all of this without having to write down this part right here. You could just go to 20, 10, -5, and 40. This was just for demonstration purposes only. That's pretty straightforward. I don't even think I need another example of that one, do I? Good, because I'm not going to. Okay, so today it's matrix, dimensions, and then doing some adding and subtracting. If you want the worksheet's going to be up here. Put it on the stool over here. If you want it, I have put it inside of Schoology as well. But I don't think I have it set up as an assignment today. I think I just have it set up as a PDF. So I would prefer that you did this one today because you're not going to be able to submit it. Just hand this to me before you leave. You should have this done before you walk out of here today. Go.
Mr. Anderson, did you say that your school knows images?
I'll be here this week after today after school. The only day I'm not available is today.
Oh, okay.
The rest of the week I'll be here. I've got a meeting after school today.